Hello everyone, I'm Felipe Hoffa from the Google Cloud Platform team, and today's show is about BigQuery, Python, Pandas, and how to tie everything together. I have with me Collin Sellman from Pearson, the big education company, and he has some very good news about BigQuery and how it's getting connected now to Pandas. We'll have some demos. So welcome, Collin. Thank you for coming.
Thank you for having me, Felipe.
Yes, you are the director of data science at Pearson.
I am.
Pearson is not a startup.
It is not a startup. It actually started in 1844, and today we are a global education company, but we also own the Financial Times, so a lot of people don't know that about us.
Oh, that's pretty big.
It is a big company.
You're everywhere, and you are the director of data science.
Data science, yes indeed, and what that is specifically, I'm tasked with trying to make our products better, specifically for student outcomes. And so the group that I work in is the K-12 education group, and specifically what we look at is products that are used in the classroom. So it could be a product that is used throughout the course of a year or a semester by a student that needs to catch up. Could be a product that they're using just a part of their normal classroom activities. And as a data scientist, my job is to try to figure out how to use the data that we collect from a lot of our users that use our products and both prove that our products are effective, so when a student uses it, that it's going to give them some better learning outcome, and also to try to make them better. And so that's a very exciting time to be in education because there's lots of really cool things that we're able to collect now that we weren't able to collect 5 years ago. So you can imagine when it was just textbooks didn't collect data. And so you couldn't look at how students use textbooks or what pages they focused on. Now with digital products, we can do a lot of that.
That's great. So you have 6th graders everywhere using Pearson products.
Yep.
They are interacting with them. You are collecting data. You're able to tell how they're using it, when the tests are.
Yep, and our whole job is to try to make those products better. So all the data collected is all anonymous, but basically we look at things like that, like what do students use? What do they use in some cases more than other times? And in a lot of cases, we try to look at how we can sort of prove that that use is leading to a good student outcome. So how can we look at what a student knew, let's say before they started using one of our products, to what they knew after they started using one of our products. And hopefully we can statistically show that we're making a positive impact to what we call student efficacy, or the efficacy of learners and teachers as well.
Well, that's amazing, helping our students.
Yep.
And what are your tools? How do you do this?
So me personally, I happen to really like Python, and I was introduced to a library within Python called Pandas a few years ago, which has been great because a lot of the problems that I have as a data scientist is not sort of doing the end analysis, but it's in taking all the data and putting it into a format that I need to see. So, how do I group these types of data by different parameters? And Python and Pandas in particular is a really great way to take source data from different databases, sometimes from APIs, sometimes from CSVs, all sorts of different ways. Put it into, traditionally what I do is look at sort of a denormalized table of anonymous students by some variables and then do analysis. So a lot of group bys, using Boolean vectors to sort of filter out and look at different aspects of the data.
And BigQuery is your database?
It is. And so one of the things that we were fortunate enough to do this past summer is we reached out to the Pandas community and asked them if they would like us to try to contribute a connector from Pandas directly to BigQuery. And so because I had already been using BigQuery and sometimes using the base API, especially on a desktop, was a little bit problematic compared to like a Pandas MySQL connector, which is really easy. We decided, hey, let's try to do this. And my two sort of coworkers, Jacob and Sean, and I, during the summer sort of worked on this open source project, which was really great because the community is really great, really active. And so far, it seems like people are interested in seeing how our submodule within Pandas can actually enable them to connect directly to BigQuery for both reads and writes.
Yeah, so from now on, from version 0.13,
yes,
Pandas has native BigQuery support?
It does indeed. It is an experimental feature now because we're still looking at sort of proving out some things and really looking perhaps in the future to add some more things in, but it's definitely in the .13 release.
Yeah, I'm so glad you started with this project, the community received you. Can you tell me a little about why you are using BigQuery? Why?
Well, it actually started sort of the history of how I found out about BigQuery in the first place is I was actually on Twitter and I was following someone that was talking about sort of new database technologies, and this was several years ago, and they tweeted a link to the Dremel technical white paper. And so I started to read that, and the user sort of persona that whoever wrote that used, her name was Alice, and it was talking about Alice internally working inside of Google and looking at sort of analyses that weren't necessarily a good fit for MapReduce or sort of traditional relational databases. And when I was reading that, I was like, Alice is me, because I'm very much having this problem, because I was at that time, and still continue to use Amazon and MySQL and some other things, but some of the types of queries that I was doing with these big denormalized tables were in some cases taking 10 or 15 minutes. And so that could take a lot of my time, especially if I'm doing an exploratory analysis. And so that's right after that, I can't remember exactly, after reading the paper, I heard that BigQuery was coming out as sort of productized version of that Dremel technology. And so as soon as it came out, I signed up, I started playing around with the first data sets, and then uploading some of our data, and that's sort of where I started with BigQuery.
That's awesome. So right now, your workflow, instead of waiting 15 minutes, 20 minutes to get answers, you are able to get it.
Well, in seconds, depending on the query, but a lot of, in some cases, I'd see like a 50 to 100 times speed up in some of the queries that I was doing. And I think it's also a lot less sort of overhead in terms of managing, the type of instance I have, and the size of the disk and all those sort of things that I would have traditionally had to do in Amazon. And so it was simpler from a lot of different reasons. And also, one of the things that I also like about it is that it has the web UI. So although there's some great clients for MySQL, having the web UI makes it really sort of easy for me to do work at home, do work in the office on different computers, and take it and do whatever I need to do anywhere.
By the way, a small trick for the web UI, if you have been using it, have you used autocomplete?
Oh, I just saw that. I just saw that recently. And so that was a very exciting thing, because when I first started using it, it didn't have that. And I kept hitting tab and nothing would happen. And so now that it has it, it's really exciting.
Yeah, if you are writing queries on the web UI, you can press tab and it will autocomplete the function names, the dataset names, wherever you need, you will have right there in your hands. Try it out. But going back to the Pandas world, statistics, we are doing high-level analysis, we are learning how to make the products better.
Right.
Can you show me a demo of this?
Actually, I'm going to have two of my coworkers who are here with me today, who helped us and really wrote most of the contribution that we tried to make to the community of Pandas. They're going to give you two different demos. One's going to be more of what we would call a confirmatory analysis, and one is going to be an exploratory analysis, both using Pandas, using our new read GBQ method, and BigQuery.
I'm very excited. Let's get to the demo. We'll have a minute or less with the Studio Magic to prepare the demo. So, are you ready now?
I'm ready.
Let's go. Okay, so we are back with Collin and Sellman from Pearson, and now with Jacob Schaer. We are going to demo how they are doing data science at Pearson. Hi, Jacob.
Hi, thanks for having us.
Thank you for being here. You've been working with Python, we've been working with Pandas, you have some data science to show us. What are you doing? What are we doing today?
Correct. So as Collin said earlier, we're planning on demoing a bit of a confirmatory analysis, that is, using a specific method to answer a specific question. And by doing so, we hope to demonstrate how we use BigQuery in our analytics.
That's awesome. And what's the question that we want confirmation for today?
So today we're looking at student use of practice assessments. We're hoping to see if the questions are too difficult or too easy for the students.
I see. So you have students everywhere in America. They are answering questions on an interactive test?
Correct, one of our online platforms.
That's awesome. And now we are able to tell if the questions are hard, if they're fair, if they're easy.
Right. So the goal is to look at the difficulty and assess whether the tests are meeting the original goals.
How are you able to tell that?
So we have the raw item responses given by each student, and we're going to run a Rosh item analysis, which is a simple model for students taking tests that accounts for their ability as well as the difficulty of the question.
Can you show me more?
Sure.
Awesome.
So we're going to start off by importing our submodule. As we mentioned before, there's now the GBQ in version 13 of Pandas. So typical boilerplate, we're going to import it. And now we get to start our query preparation. The key requirements for this query was that we have to have the first time a student has seen a question. This is challenging because some students can retake the tests, can retake the question, or could even have seen the question in a different context.
I see. So you have a big data set of every time students have answered the question?
Correct.
And with BigQuery, you are filtering out only the first time they saw that question?
Where possible, and that's where Pandas will come in to help clean this up.
Awesome.
So what we do is we select basically the raw data we need, the student's anonymous ID, the question's ID, if they got it right or wrong, when it was created, and when they last updated the score. This is coming from a set of 14 questions that were part of an assessment in one of our products. Specifically, this was a writing for 7th graders. And we're filtering on whether it was the first time they'd seen it within that assessment, and if it had valid timestamps and valid status.
So that query runs in seconds. You get data into Pandas?
Correct. So if we save this query in here and we run it using Pandas, new readGBQ method.
Let's see how long it takes.
Yes.
Are you connected to the internet?
Yes.
Awesome.
So it took around 10 seconds to run the entire query against our data set. So now that we have the data, we still have the issue of potentially retaking the entire assessment to deal with. And we can do that using Pandas. So Pandas has a method, drop duplicates, which keeps the first occurrence of any pair or n number of columns you'd like. So we're going to do that. We want to take only the first occurrence of any pair of student IDs and item IDs. So we drop the duplicates, and this is a subset of what the data is. We can see we have the student ID, the question they took, and whether they got it right or wrong. Now we need to pivot the data. The goal is to have it in a matrix format.
I see.
So the goal is to have it in a data structure where the student's ID is on the rows, the columns are the question ID, and whether they got it right or wrong is the cells.
I see. And you were going to do that with Pandas?
Correct. There is a way to do it with BigQuery, and this is in the documentation, but we're going to demo it with Pandas. So we can do that with the pivot method that comes in Pandas on data frames. We specify the index, the item ID, and the value we'd like in the cells. We run that, and we take a preview at it. So we can see it's generally in the form we want it now. As we described, we have it students as rows, questions, etc. But there's a problem still. We still have missing data. This makes sense in this context because students didn't have to finish the tests. They could have dropped out early. They could have had a session problem.
So there are a lot of blank spaces in the matrix right now.
Right.
And how do you filter that out?
Right. So Pandas, again, has a drop NA method, which takes out any missing data. So we basically take out any students that didn't complete the test.
Let's do that.
And as you can see, all the rows with the missing data are gone.
Awesome. So now you had your whole data set, you filtered it out with BigQuery, now you cleaned it up with Pandas. And are you able to tell me if it was a hard question or an easy question?
Sure. So for that, we're going to turn to R.
R?
Yes, new R. It has a very handy method for this, the LTM package for doing item analysis. And with the help of the RPy2 Python package, we can work directly with R straight from Python.
That's so cool. So right now we're combining BigQuery, Pandas, R.
Right, and that's sort of what Python is good for, is combining a lot of things. So what we're going to do is we're going to import RPy2, and we're going to load the LTM library, and we're going to perform the ROSH method that's contained within the library.
Let's see what we get.
So it's loading the R library, and we've printed out a few of the interesting statistics that it gives us, the numerical statistics, such as the frequency of students who got a certain number of questions correct, the alpha values for each question, and the various coefficients associated with the assessment.
Can we get a visualization of it?
Right. So another cool feature about R is its really great graphing functions. And we can take that analysis and plot it very simply in the same way using the plot methods built in. And we get a graph that looks a little bit like this.
And what does that graph mean?
So this graph is a comparison between the students' ability levels and their probability of getting a given question correct. As you can see, all 14 questions are represented by a line on the graph. And the key thing to look for here is the ability level. So a student with a 0 ability level in this case would be the average student in the class. And for that, the average student got at least every question right with 80% probability.
That's an amazing visualization, but I have a question for Collin.
Sure.
A big question we all have in data science. How do we transform these insights into action?
Well, it's an interesting question. I think that's really what makes data science different, maybe, from analytics, is that our goal in data science is to take an analysis and build knowledge and then do something with it. And so in this particular case, when we wrote these items, we were trying to target a range of different difficulties. So you think about a practice test for students. You want some items that some students are sort of earlier on in their knowledge can answer, and some students that are further along can answer these more difficult items. So ideally, a practice sort of product like this has some items that are more difficult, some that are sort of middle of the road, and some that are easier, so that every student can see a little bit of progress. And so specifically for something like this, what we've done is worked with our curriculum teams, so the teams that are actually writing these items, and trying to target these difficulty levels, and we loop back with them and say, here's what we see. So in this particular case, you can see that all of the lines are sort of shifted to the left. We'd rather see a distribution of those lines sort of going between -2 and 2. And so we're feeding that information back into the curriculum teams to say, okay, in this case, this is what we're actually seeing empirically with this data. And that's the specific question that we answered, and that's how we sort of improve our products. And you can imagine if we didn't do that, we would have, in this case, a practice exercise that students are going through that they all find very, very easy. And so it wouldn't be accomplishing our goal, which is basically to make this practice product to help them grow and mature in terms of, in this particular case, I think looking at reading for 7th graders.
Yeah, that's awesome. So the curriculum team is getting real feedback, real data, and all thanks to the analysis you're doing. That's amazing.
Yeah, it was really useful for the team.
Thank you, Jacob. Do we have another demo coming up?
Correct. So Sean is going to come on and do a bit of an exploratory demo for you.
Okay, let's have Sean here then. Give me a minute and we will be right back. Yes, and we are back with a second demo now with Sean Schaefer.
Yes. Hello, Felipe.
Hello, thank you for being here.
No, thank you for having me.
Yes. What do you have to show us today?
Right, so today I'm going to be going through a bit of an exploratory analysis.
Exploratory analysis?
Exploratory analysis. So before, Jacob showed more of a confirmatory analysis, and that's where he had a specific hypothesis that he wanted to see if his data supported it. So what I'm going to do is we're going to kind of look at the data without having any prior assumptions and see what kind of conclusions we can come up with based on visualization of the data in this case.
Cool. And what's the data we are looking at?
So this data is going to be student answers to questions on assessments. So what we're looking at initially is just the students and the questions that they ended up taking. And so we're going to visualize that and see what kind of relationships we can see. But the key point here is that the students were given choice in which questions they wanted to select. And so what we're really trying to look for to see, is there any trends or any kind of relationships between the items that the students selected, those questions that they wish to take, and see maybe what we can take away from there.
So students today are able to choose which questions to answer?
These are practice tests, yes. So they, in this specific case for this product, they have the choice of which questions they feel they would want to practice the most.
Oh, let's see what they did.
Okay, so what we're actually going to use here is we already have our data stored in Google BigQuery. So we're going to use our GBQ module to pull that data into a Pandas data frame. And then we're also going to utilize another Python library called networks, which is going to allow us to create a network data structure, which is just essentially connections between objects. So I'll go ahead and actually run the code that shows the network, and then we can go in and have a look and see what it actually looks like.
Let's see how it works.
Okay. So right now we have Google BigQuery actually pulling the data, and we're going to be able to see about how much time that takes to pull into a Pandas data frame. Looks like it took us about 8 seconds. And now we're going to have networks take our data and create a network graph out of that.
So what's happening now?
So we are still waiting on the network to come up. It actually is a little bit computationally expensive, but we'll be able to visualize it in just a second here.
So you got all the data from BigQuery filtered out, and now you are processing everything in your computer.
Correct.
With network, you're getting a...
So now we have a network graph here.
Okay.
And so basically, you'll see that there are really 3 main components to this graph. We have red circles, we have blue circles, and then we seem to have these black lines between them. So what the red circles indicate are students, and then the blue circles are the questions that they had taken, and the lines indicate the connections between them, which means that a student chose to take this specific question.
So here we can see clusters of students.
Yes. So if you're looking at this, that's what stands out most to me. We have these certain clusters, and right now we may not be entirely sure what that means. It could be specific subjects that those students are trying to study. What we'll probably want to do is drill down a little bit further and see if we can make any other meaningful conclusions based on filtering with the data that we know we have.
So you have a cluster of students that like chemistry, some focus on
Possibly,
math.
yes.
Yes. How can you go deeper into this?
Well, we know based on our data that we have other things that we've collected. So another thing that we've collected is the time that it took the student to answer a specific question. And so we may want to look and see how time is related to these clusters and see if we still see these kind of clusters if we filter out for a specific time.
Okay, let's add another dimension.
Okay, excellent.
What do we find?
So first thing we're going to have to do is, since in our initial query we only were looking at the student IDs and the questions, we want to also pull the time it took for them to answer a specific question. So I'll go ahead and pull that data from BigQuery into Pandas using our GBQ module.
And you asked me about data science earlier. This is on the exploratory side. I've found that it's very much like this. So you start looking at the data, you see something, and then it sort of raises some other questions that you didn't have before, and so then you need to rerun it, add another component or another feature so that you can look at it. And so this is where sort of that being able to do it very quickly in BigQuery is a big improvement in my overall workflow, especially dealing with large data sets.
Yeah, you can fit so many more questions in 1 hour.
Yep.
Exactly. So it looks like we got our data into our Pandas data frame. And let's first just have a look at the distribution of the time that we have so that maybe we can see what a good filter would be based on how long students are on average taking for these questions. So one cool thing we can do with a Pandas data frame is we can pull one specific column out and plot a histogram of the values in that with a very simple function call. And so I'll go ahead and run the code that does that, and we'll see visually the different counts of our distribution of values. So it looks here like we have the majority of the students answering in under 20 seconds or so. But we have
a fast student.
Yeah, so 20 seconds you could think maybe an average amount for a question, but it actually looks like we have a lot of students that are taking them very quickly. So in this first bin, we have students that are taking it in about 5 seconds. So that's something that we might want to investigate further, because 5 seconds is actually very quick to answer a specific question.
Yep.
Especially the first time you've seen it, right?
Exactly.
So it takes some time for the question to come up, for you to read it, and then come up with a response.
Exactly.
Right. So what we can do now is plot our network once again, and this time we'll try and look at what's going on in those cases where the students are taking 5 seconds or less to answer the question.
I see. The special kind of student.
Yes. We aren't quite sure what's going on yet at this point. So we can go ahead and run that query again, and this time we will add the filter for 5 seconds or less, and we'll build out our network graph once again.
I love network graphs. Even if I don't really understand what this one is doing.
It's an excellent way to visualize the relationships between two specific components that you have, yes. Especially if you're not quite sure what those relationships might be yet.
And once you discover what's happening behind, how do you turn this into actionable?
Well, I think in this particular case, we're looking at, and I think as we look at sort of the visualization, one of the things that we're focused on is how to make our programs more effective. And so when we're looking at this particular case of looking at students that took less than 5 seconds, it could be that they're guessing. And so the interesting thing that Networks does, in addition to sort of visualizing it, is think about it like sort of a dictionary or like a JSON format where you can take basically students and questions or nodes, and then there's an edge between them. So if the student has taken this question, there's an edge, we could add things to that edge. For example, did they get it right? Did they get it wrong? And so if we wanted to look at the network of students and items that were taken in less than 5 seconds, what was the proportion that were correct in that versus maybe the students and items that were taken 5 to 10 seconds. So you could imagine that we can think about how students are taking it, and potentially we could make our products identify perhaps when students are guessing, or maybe change the UI to talk to students about, hey, maybe you should spend a little bit more time looking at this question because you're more likely to get it right. But the network sort of concept is really interesting because you can add whatever sorts of attributes that you would like. So you could add things like, did they get it right? Did they get it wrong? What was the order that they took those questions? So again, in this case, students are allowed choice. So do they start with the harder problems in the algebra section, or do they start with sort of the more basic skills? Because our program is sort of designed around that. And so we can visualize all those different things. In this particular case, there's not a specific answer we're coming up with, but we're really exploring. And as we actually did this this past summer, we found some very interesting things that definitely informed the design of our products in terms of how we presented questions and how we sort of gave students feedback when they got questions right and wrong.
Okay. That's so cool. I'm so excited about this, how you are collecting data. That's a completely new phase for education.
Right.
You're not having passive books, you're having interactive data.
Yep.
I know you will be able to collect data with Google Analytics soon.
That is one of the things that we're also looking at. So we use Google Analytics quite a bit differently because we don't use it for marketing or sales conversions, but we use it in some cases to track usage of our products. And previous to having things like Google Analytics, we might have done a field study where we partner with a school and we have researchers in the field, in the school, observing how teachers and students use that. And so we continue to do that, but imagine taking Google Analytics usage data for those same products and overlaying it on top of that research method. So now we have a multi-method design where we're both doing sort of interviews, observations, but we can look at objective data trends for usage across the entire time that we're doing that field study. And so that's a very exciting thing for us, not only at Pearson, but I think in education overall, is all these new types of data that we've never had in the past. And you can imagine what happens to usage of a particular, so let's say, product or asset or interactive thing across an entire semester of a school year, right? It's very difficult to get that when you're observing for a week. But if we can collect that data across a whole semester, across a whole year, it gives us insights, again, to improve our products, to make them more effective and make them better for students and better for teachers.
That's awesome. And I'm so happy that you're sharing your methods with us, that Pandas now has the BigQuery connector. I know you're just getting started with it. The community will grow around it. You will stay part of the Pandas community.
Yes, we definitely will be.
Yeah, we hope so. And for those that maybe haven't heard of Pandas, there's a great book called Python for Data Analytics that Wes McKinney, who is one of the major contributors to Pandas, has written. And I really recommend it. It's a really great, accessible book to get you started with Pandas. It doesn't have the read GBQ method yet, but you can learn about that on the website. But it really gives you a lot of the great things that Pandas can do with time series data, a lot of really powerful things there, and all the different types of ways that you can analyze data using Python and Pandas.
That's awesome. Thank you for coming today. Thank you, Jacob. Thank you, Sean. Thank you, Collin. I hope to stay working with you.
Yep, likewise. It's been great. Thanks for having us.
And thank you, everybody, for tuning in. Try BigQuery out. Try these methods out. There are really some amazing questions that no one has asked before, and you are able to ask now. Until the next time.